Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hi again, everyone. Welcome to the SMJE 4233 lecture on industrial hydraulics and pneumatics. Today we will look at the second design example related to Bernoulli's equation. And what I'm going to show you is given a system, how we can design the system based on the requirements of the problem. So here the question is given in the e-learning, and also you can download the question from the link of this video. So without further ado, let's look at how we can solve this question. So basically what we have here is a mechanical and hydraulic system that has been partially designed to turn a load. Some of the design parameters are given, such as the part inside diameter, specific gravity, oil tank, and so on. So there are 2 points, and what we want is to be able to achieve a certain pressure requirements at the hydraulic motor. So there are 2 points, 1 and 2. In between the 2 points there's the pump. So let's write the Bernoulli's equation. So there are 2 points, so we're going to write the Bernoulli's equation between 1 and 2. And we're going to use the head form of the equation. We covered this in class. So the head form consists of the Z1 plus P1, the pressure at point 1, over the specific weight plus V1 squared, plus the head due to the pump minus the head due to the motor minus the head loss due to friction, equals to the similar components in at point 2. So from figure 2, we can see that there's no motor at point 1. So that implies Hm is equals to 0. Okay, the motor at point 2 is just it's not in between point 1 and 2. Okay, so we don't consider that particular motor. So next we assume fluid stationary at 1. So that means the velocity of fluid at 1 is 0. So that becomes 0. Next, the difference in elevation are also given. So Z2 minus Z1 is equals to, as shown here, you can see if we label this Z2, this is Z1. So Z2 minus Z1 should be equals to 20 feet. So it's also given that there's a head loss between station 1 and 2 due to friction equals to 40 feet. So we can write it down. Oil tank is vented to the atmosphere. That implies that the pressure at point 1 or station 1 is equals to 0. So this component is 0. Next is okay, let's just write the equation. The Bernoulli equation. See what else that we know about the problem based on the parameters given. So let's look at the parameter HP, which is the head due to pump. So from equation 3.29, we know that the head due to pump is equals to this equation. So let's label that equation 1. So the expression for V2 will be based on the flow rate divided by the area. Okay, that's by definition. And the area is given by pi radius squared, and in the question is given the diameter is 0.75 inches. So if you want to convert to feet, we have to divide it by 12 and then divide it by 2 to form the radius. Okay, that's the we use 12 because 1 feet or 1 foot is equals to 12 inches. Okay, so if we multiply all these constants, we get this number. But remember, then Q in this equation has to be in cubic feet per second, okay, in order to be consistent. But in equation 3.29, it is defined Q there to be in gallons per minute. So there's no choice in that equation. So what we can do is we must ensure all the units are consistent. So let's stick to Q in gallons per minute, and we can convert it to find V2. So V2 is equals to Q divided by 449. That's the conversion factor divided by the E. So we can just simplify that to Q is equals to V2 is equals to Q over 22.04. Okay, next, SG is given in the question. Specific gravity for the oil is 0.9. So you can write it down. Okay, the idea is we want to simplify equation 1. Substitute all the values that we know. And then we need, okay, G is 32.2 feet per second. So what we're going to do is we're going to substitute all the values we know, and then we solve for the pump parameters. So specific weight of oil can be found because the specific gravity is given. And remember, specific gravity is just the specific weight of oil divided by the specific weight of water. So therefore, specific weight of oil can be found to be 56.16. So now let's see what happens to our Bernoulli's equation. It has been simplified a lot, except for the two unknown values of pump horsepower and the flow rate. So I'm just going to write the required pressure at point 2 equals to the rest of the parameters to the right hand side of the equation. Okay, so let's simplify this further. So V2 we have the expression in terms of flow rate. Okay, that's the expression we found before. Okay, so we're just substituting all the values. You can see the only two unknowns are the pump parameters. That's the problem where we want to choose a pump such that the pressure is achieved as required. So just simplify the equation further. So if you do that, then this constant becomes 31283.05 times 56.16. So this is the equation that we can use. Okay, there are three unknowns, but we know P2. So we want P2 equals to okay, in between 248 and 300. Right? But that is in PSI, pound per square inch. So if we want to substitute this P2 into the equation, then we have to convert it into pound per square feet. So say we want it to be 275, and we need to convert this to pound per square feet. You can do that by multiply it by 144. So this is the number we achieved, 39,600 pound per square feet. Okay, so now we have two remaining unknowns. We just need to choose the HHP and the Q to achieve that particular value of the pump. Right? So we can use trial and error, or in this case, I will just use Excel. Okay, or you can write a simple program, or you can just use Excel as shown here. So you just key in the equation. So you have the two unknowns and the P2. So this green, the equation in the green box, I've keyed in the cell F for the P2. Okay, and once you have keyed in the formula, you can use you can just assume a certain value for Q. So here I've keyed in the P2 and then formula, okay, P2 formula, and then we can use Excel goal seek function. If we set the flow rate to 15, yeah, I'm just setting flow rate to 15, typical pump value, then the hydraulic horsepower is given to 2.61. Okay, so if you want to convert that hydraulic horsepower and to find the pressure, we can use the equation 3.25. Then you can see that that's the pump parameters. Okay, Q is equals to 15, that's in gallons per minute, and then the pressure of the pump is 298, so almost 300 psi. So a pump with flow rate of 15 gallons per minute and 300 psi should work to solve the problem. Okay, so there are other combinations that also work. You can try that on your own. So that's it. Thank you very much. See you next time. Assalamualaikum warahmatullahi wabarakatuh. Bye bye.